Emir and Ed play each other at badminton, and for each game, independently of all others, the probability that Emir loses is 0.2. Find the probability that in 9 games, Emir loses exactly 3 of the games. Okay, our binomial spider senses are tingling. 9 games, probability of a loss is 0.2. They were independent. It's either a win or a loss. There are no draws. Definitely going to be a binomial distribution. Let's set out the distribution. So x follows a binomial of 9, 0.2. Okay, and we're looking for the probability that x equals 3. This can be done on your calculators. This can be done looking up in the tables and subtracting 2 values from each other. Or we can actually use our probability statement for the binomial. Just to remind you, this statement here, which in this particular case would be 9c3, probability of success to the power of 3, probability of failure to the power of 6, and just that typed into our calculators. And from that we get 0.1762 to 4 decimal places. Okay, for this question, if we were to use the tables, we would have just looked up the probability that x is less than or equal to 3 and subtracted the probability that x is less than or equal to 2. And that would have left us with the correct answer. On our calculators, we would have used the BPD, so not the cumulative, but BPD, and it would have been BPD, put in your 3, your n value of 9, and your probability of 0.2, and it would have given you the answer you were looking for. And it would have given you the answer you were looking for. Okay, so the next bit of the question is asking, find the probability that in 9 games, Emir loses fewer than half of the games. Half of 9 games is actually 4.5 games, which isn't an integer value. It cannot be an amount of successes. So we're really talking about, it's a non-integer value. It doesn't really exist. We can't have 4.5 successes. You can't lose 4.5 games. You either lose or you don't. So this is actually equivalent to the probability x is less than or equal to 4. Okay, and once again, this can be looked up in the tables. I don't recommend doing this by hand at all. Look it up in the tables or type it into your calculator, and we should get an answer of 0.9804. Okay, once again, on your calculator, you could have done this. This is a cumulative distribution though, so we would have been using BCD, and you'll be typing in BCD 4. We've still got n equals 9 and p equals 0.2. So either way, we would have got our answer from this. Just make sure that the working out that I have in black is definitely represented, and that would be worth all of your marks.